Hey guys, welcome back to Chilifili, and in this video we are going to implement the simple linear regression using Scikit-Learn library in Python. And if you have watched my previous video, then you might know that we implemented it using the built-up function, or we can say that we build a function and find the values of slope and intercept without using the Scikit-Learn library. And as you can see that it was quite a long process. But what if I tell you that we can do the same operations without this much lines of code and with only 2 or 3 lines of code? That is interesting, right? So let's get started. And here we go. Okay. So these are just basic steps. If you already know, then you might want to skip it a bit. So just one thing you might notice that is different. That is we have included or imported a linear model from a library called Sklearn. Okay, so why we are implementing it? Because we want to calculate the value of slope and intercept without creating any function by ourselves. We just want to use our libraries to calculate the value of slope and intercept and just give it to us. All right. So after then we are going to read the CSV data file, and here are the data. Okay, so now we are going to select some useful features from. We are going to plot our scatter plot. Okay, so here is the scatter plot. It was the same as we found in this video or this article. Okay, and after that we are going to divide our data in testing and training data, so that we can, after we train our model, we can actually test our model to see how accurately it predicts our data. Okay, so now we are going to use the scikit-learn library to find the intercept and slope of the data. So this is new for us. So here we're going to import the linear model from sklearn and then define variable regression regr equals to linear model dot linear regression. Now we have to do this because we want to find the slope and intercept from the library. We are not going to calculate, or we are not going to use this function that we built here, that is here. We are not going to use this simple linear regression function. We are just going to use this regression variable or linear model module, which is in our sklearn library. So okay, here we have two variables, which is train x and train y, which is basically just engine size and CO2 emissions. So now we have to fit our training data in our regression function so that it can give us the value of slope and intercept by itself. We are not going to calculate it with a function. It will just give us the value of slope and intercept. So here we can see that we have values of coefficient and intercept. So the coefficient is the slope of the data, and we just have to type this regression dot coefficient underscore, and this is the zeroth row, and this is the zeroth element in, and probably this is a one-dimensional array and this is two-dimensional array, and you can see it here. Okay, so we have regression dot coefficient and it is a two-dimensional array. So in two-dimensional array, so it returns number of rows and number of elements in it. Okay, so the shape function will give us it has number of rows as 1, and it has one element in it, that is 38.79, and our intercept will give us the one-dimensional array, so it has the only one element. Now this one represents the number of elements in a one-dimensional array. Okay, so let's get back to here. So we can here easily plot a coefficient and sorry, here we can easily get the coefficient and intercept value. Okay, now we are going to plot the regression line. Now you might notice that this is the same as our this article, right? There is no difference between these two. These are the same because we are, what we did in this article or this video, previous video, that we just calculated the slope and intercept value by ourselves. Other than that, we are going to use the same process like reading the file and plotting the data points. So here it is the same. Here we just use the regression coefficient, and here we use the slope that we have already defined with our function. So moving forward, okay. So now we have to predict the value of CO2 emissions, which is the same function as this. Okay, you can see this, and I have already taken this same number of engine size, so it is easy for us. So here we can see that the estimated emission is 262.95, and here is estimated emission is 261.40. So there is just a little variation in this because I might have used different data to train this model and this model, because in this model we have used the complete data to train our model, but in this video we are going to use just the training data to calculate our model. You can see it here. Okay, so there might be a slight variation, but if you use the same data to train the train model in both of the cases, then you will probably get the same answer for it. Okay, so here what we did is we predicted our value of CO2 emission with y equals to mx plus b formula from here, and then we just plugged in our x value, that is my engine size, and we get our estimated emission. I think this is pretty straightforward for us to now understand. And okay, now we are going to check the model accuracy. So in my previous video I talked how we can implement or how we can check the accuracy of a model using uh, without using Scikit-Learn library. So you can see here we have a lot of error calculating functions like mean squared error and mean percentage absolute error and mean percentage error and residual sum of squares and many more. So here we are going to find the value of this error function using just one line of code. Here you can see that. See, first of all, we need to import the library that calculates the error cost, or which gives us the error value for a particular error function. So here we have imported the library called R2Score, and we have just this is just the basic stuff and taste underscore y underscore y. This is how we are going to predict our Amazon for our data set. Okay, so now we are going to find the mean absolute error. Now we want to find the mean absolute error between our actual value and our predicted value. So our actual value is taste underscore y. This has CO2 emissions in it, and our predicted value for CO2 emission is stored in this variable taste underscore y underscore. Okay, so now what we need to do is to just calculate it like np.mean np.absolute test y underscore test y. So this will just give us the mean absolute error, and the same for mean squared error. And the best thing about this accuracy is accuracy library or R2Score library is it gives us the R2Score without any calculations like you might know that calculating R2Score is quite difficult than finding the value of mean squared error or mean absolute error. Okay, so here we can easily calculate it using just this is predicted value and this is our actual value. So our R2Score is 0.71, so this is quite good. Okay, so I think that's it for this video, and in conclusion we can say that the line of code required to find regression line is much harder than doing it with the raw Python code, but it is very important for us to know how the code works. Okay, so I think that's finally it for this video, and if you guys like this video, then please what do you say, please press the thumb icon, okay, or the like icon. And if you want to modify this Python notebooks, then you can put your mail in the comment section, then I will send it to you. Okay, and you can obviously visit my blog which has all the article posted in here, and I will put the links in the description if you want to read it. Okay, so thank you for watching, and I will see you guys in the next video.